Okay, our temat of our papers is improving N-NEH algorithm by using starting point method. My name is Radosław Puka. I write this paper with Bartosz, Łamasz, and Iwona Skalna. They are in Athens, but they don't speak, so I will try speak a few words about this temat. And the topic of our paper is permutation flow shop problem. In this problem, we have N jobs and M machines. What is the important that in each job, the order of the machine is the same. So if for every job, the first is machine 1 and machine 2, second, third, and etc. We choose go function and minimize make span. And this problem for machine greater than 3 is NP hard problem. And this is the pseudocode for N-NEH algorithm. So we have N jobs. We sort in non-increase order that is total processing time, and then we insert in this order in the partial scheduling. First we get a job with the greatest total processing time. Then we have second job, and we try when the second job will be put, that the make span of the combination of two jobs will be the minimum, and then we try with next jobs, and we choose always the sequential with minimum make span. This is the simple example. We have 5 machines and 5 jobs, and we ordered in non-increase total processing time. That will be job 3 to 1, 4, and 5, and we scheduled it. So the first we have job 2 and 3, because the make span of this scheduled, partial scheduled, is the minimum. Now we put next job in position 1, 2, and 3, and we check where is the minimum value of make span, and we continue, and we give scheduled with make span 421. It's this scheduled, and N-NEH algorithm is ours algorithm is the improved N-NEH algorithm. We use in this algorithm N-list technique. N-list is the list of jobs that candidate to be scheduled in each move. So as you can see, we in each step we have 2 jobs, because N-list in this case is equal to, and in each step we check the partial scheduled with this job and this job. We have the minimum make span with job 1, job 3. So we delete job 1 from N list and add the next one job from the order. And next step we does the same as the first step. So as we take the sequence job 1, 3, 2, 5, and 4, that the make span is 413. So as you can see, is less than the N-NEH, and we have some modification in our paper that we call starting point method. The method is compare the N-NEH and N-NEH algorithm. So we in the first case steps we used N-NEH algorithms, but after the case steps we used N-NEH algorithms and scheduled jobs with N-NEH. One of important case that the plus is meaning that we have choose the best from the many solution that as you can see N prime is from the ranging 0 to N prime. And I have one example more to explain our proposition, the starting point method. We have 5 jobs and 6 machines. And N-NEH algorithm, we put first job, next 1 jobs, and we put in the first and second place, etc., etc. We have equation job 2, 5, 4, 1, 3 with make span equal 619. N-NEH algorithm with N list equal to, we have we put the first job 3 and next job 1. As you can see, we choose the partial sequential job for job 1 because the make span is the smaller for this sequential. And we delete from N list job 1 and add job 5. And etc., etc. And in the last step, we have sequential job 2, 5, 3, 4, 1, and with make span 616. 619 was in N-NEH, 616 is in N-NEH, and with starting point technique equal to, we have make span equal 604. The first 3 steps is the step from N-NEH, yeah, from N-NEH, and 2 last steps is from N-NEH. So after 3 steps, we use N-NEH with N list equal 2. We use 2 effectiveness measure. The first is average relative percent deviation. is the measure is inform how far the obtained solution is from the best known solution, and the second measure is a CPU. This measure inform how much time the algorithm needs to return the solution. And we have two results. As you can see, we use three benchmark to testing our algorithm. Benchmark Tylard, VRF small and VRF large. And we use 10 starting point value for our analysis. And as you can see, the best results we have for small value for starting point. For starting point value equals 0, 0.1 n, and 0.0.2 n. We have in this slide we have results for measure ARPD for SP plus algorithm. This is mean that we have for each starting point the best from each point that was less than this one or the next one. So as you can see, the greatest decrease in the ARPD values can be observed for smaller values of n prime. And the next one is ACPU. At the time of we need to get the solution from algorithm, and for the n list, the time for the longer n list is very bigger than the smaller n list. In starting point method, the time is bigger, but not that bigger that as bigger as n list technique. And the last slide is the presentation on comparison with other methods for Tylard benchmark. As you can see, our results, our solution is very good. The better is only FRB algorithm, but this algorithm is non-constructive. This algorithm have the deconstructive phase and constructive again, but our algorithm is only constructive. So it's the best from the world of constructive algorithms, and I think I will be ending. So thank you for your attention.
Thank you very much for your presentation.